Assalamu alaikum, welcome back, guys.
Alaikum salam, hello.
وعليكم السلام هلا.
Okay, guys, before we start STP algorithm, how it works, let me show you one thing. I have dropped 3 switches and I'm just connecting them with each other. Port number 2 with port number 2 of switch C and the port number 3 with port 3 of the switch P. And let me start this topology. Okay. In switch A, I have to give this command display STP brief, and you guys can see this port number 1 of switch A, the port number 1, this is acting, its role is the root port. This is acting as a root port. And the port number 2 is in the block state. This port is in the block state, is in alternate state. Alternate means in the block state. And if you look at B, so display STP brief, you guys can see the both ports rules, port number 1, this one and this one, both are acting as designated port. This port has been selected as designated port and this port also has been selected as designated port. And what about C? Let's see. Display STP brief. So you guys can see the port 2 is acting as the designated port, the port number 2, this one is acting as the designated port, and the port number 3, this is acting as the root port, And all the designated ports and root ports always is in which state? In the forwarding state. They always act in the forwarding state. They always act in the forwarding state. The forwarding state. The forwarding state. This is also in the forwarding state. BP is also in a forwarding state. But this port, which is in the block state, you can see this is in discarding state, discarding. This is the alternate port and the block port always in discarding, discarding state. And still, I'm showing you the terminologies. But we have discussed the designated port, the root port, the block port, or you can say the alternate port, and the states of every port is in forwarding state instead of except from blocking state. It is always in the discarding state. And you will see this switch B, this switch B will be acting as the root bridge, will be acting as the root bridge. So let me show you. Display STP. So nothing written over here. Okay, he has not mentioned over here, but the switch with all the interfaces acting as the designated port is always elected as the root bridge, as the root bridge. And you can see none other switch, the both ports not acting as a designated port, one is acting as a root port and one is acting as a designated port. And in switch A, you can see one port is acting as a root port and other port is in the block state. So this is switch B, which both ports acting as a designated port. So such a switch with all the ports elected as a designated port is called the root bridge. And now we need to understand, how this switch has been elected as a root bridge, the mastermind of the STP, and how this port and this port acted as a root port, and why STP put this port into the block state, and why this switch as elected as a non-root bridge, and this port, why it is acting as a designated port, and why this port acting as a root port. So we need to understand this, how this happens. So first of all, we will follow the 3 steps which we have discussed over here. So I have shown you these terminologies, and I didn't enable any STP protocol. As I said, STP runs by default in every switch. It doesn't matter it is Cisco switch or Huawei switch or Juniper switch. It runs by default in every switch. So we need to follow these steps to understand how STP works. How STP works, we need to understand, and to understand this, we will follow these 3 steps. So the first step is you need to figure out the root bridge per network. The root bridge per network. The first step. And let's draw or on topology. For example, I'm having 3 switches, switch A, switch B over here, and switch C over here. And we need to connect them. Port number 1 with port number 1, port number 2 with port number 2. It could be any combination of interfaces. Port number 3 with port number 3. So this is over network. This is over network, one network. So every switch is a candidate to be elected as a root bridge. For example, there are 3 candidates for the election for the president. Obviously, one of them will win the election and will be acting as a president. So in STP, the root bridge is the mastermind, is the king of the STP. So every switch desires to be elected as a root bridge. But who will be elected as a root bridge? Then there will be an election. We conduct an election to elect a root bridge. And what should be the criteria for the election? And what should be the criteria to be electing the root bridge? He says, first check the priority, compare the priority. So by default, every switch has a priority by default, and this is an integer value. And by default, the priority of every switch is 32,768. 32,768 and 32,768. This is the by default priority of every switch, So for the election of root bridge, he says, conduct an election if any switch, if any switch from all of them having the lowest priority, will win the election, and will be elected as the root bridge. But in my case, all the three switches having the same priority by default, That means election couldn't be conducted on the basis of priority because every switch has the same priority. So what should I need to do? I need to conduct this election on the basis of MAC addresses, So all switches compare their MAC addresses with each other, and the switch having the lowest MAC address will win the election, and who will the election will be acting as the root bridge. So in our topology, which we have discussed, which we have drawn, in that topology, the switch B has the lowest MAC address. That's why this switch has been elected as the root bridge. And all the remaining switches, it doesn't matter, they are 2, they are 3, they are 4, all the rest switches would be by default elected as the non-root bridges. Obviously, there would be one master, there would be one president in the country. So one switch will be acting as a root bridge, and all the rest switches, in our case, there are 2 switches, they would be acting as the non-root bridge. But that was according to the topology. In my case, for example, let me consider the name of the switches as the MAC addresses. For example, I'm saying this switch, this A is the MAC address of this switch, B is the MAC address of the relevant switch, and C is the MAC address of this switch. So tell me, which switch having the lowest MAC address? Which switch having the lowest MAC address?
Switch A.
Switch A. Obviously, if people know about the presentation of hexadecimal numbers, in hex, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. And the first 9 numbers, we call them as decimal number. So 9 to onwards, we represent like this. 10 is represented by A, 11 is represented by B, 12, 13, 14, and 15 respectively. So in our case, this switch having the lowest MAC address, that means this switch would be elected as the root bridge. And the rest of the switches will be acting as the non-root bridge. So the first step to understand the algorithm of spanning tree, which is STA, spanning tree algorithm, the first step we need to perform is find out the root bridge per network. And who is going to be the root bridge? There should be an election. You need to conduct an election. And the first criteria to perform an election is the priority. But by default, every switch has the same priority, so election would be in prior state. So what's the other criteria? The other criteria is to compare the MAC addresses, because the MAC addresses cannot be same. They are always unique of every device. So the switch which is having the lowest MAC address will win the election and will be elected as the root bridge. So that's how we elect the root bridge in a network. Is that clear to everyone?
Yes, sir, it's clear.
Okay.
Yes.
It's clear.
And that was very easy step. That was very easy step. Okay, fine. Compare the priorities. If the priority is same, okay, fine. Forget about it. Then check the MAC addresses. If any switch having the lowest MAC address, it will be acting as a root bridge, and that's it. But what if my desire is, according to the topology which we have drawn in NSP, that was acting as a root bridge. But what is my priority? My priority is this switch. This switch should be elected as the root bridge. And you can call it as primary, the primary root bridge. And you want this switch B, as a secondary root bridge, the secondary root bridge. The secondary root bridge. And this switch C should stay as a non-root bridge. So if you have desire, if you have the requirements of the company, for example, this is your latest switch and it has the great resources and it is very expensive and it has the capabilities. So I need to configure this switch as a root bridge. Then you can play with the priorities. By manipulating the priorities, you can select the root bridge as per your requirement, as per your desire. So how can we do that? So let me configure this switch as the root bridge and switch B as the secondary root bridge. So what will I will do? I will set the priority of switch A as 4096 and the priority of switch B as 8192. Now I will not change the priority of switch C. I will take it as 32,768. So you can always play with priority, or you can always play with the keywords, the primary. You can say this switch should be act as a primary, and instead of writing the priority, you can say this switch should be selected as my secondary root bridge. So how can we do that? And why I'm taking these values instead of any values? This is a rule. You need to select the multiply factor of 4096. The multiply factor of 4096. For example, 4096 multiplied by 1 and 4096 multiplied by 2 and 4096 multiplied by 3. So you need to carry these incremental or these multiply factor. So you will get 4096, over here you will get 8192, and over here you will get 12,000 something, and so on, 16, then 20, then 24, then 28, then 32, then comes 32,768. So you can only use this kind of values, the incremental value of 4096, or you can say the multiply factor of 4096. So how we can change the priority? For example, I want this switch should be elected as a root bridge. So, and this should be acted as the secondary root bridge. So how we can do that? So first of all, check this again. Still, the status of switch A ports are 0/0/1 is acting as a root bridge, and this port is in the block state. But once you select this switch as the root bridge, the role of both ports would be changed into the designated port, the DPs. Because I told you, root bridge always has the designated ports. So let me change the priority if I want the switch A to be act as a root bridge. So the system view. and we'll say STP and put the question mark, and you can see there are a number of options over here. So by using STP, there is a word, the priority, and you can see the word root. Okay, so I'm going to change the priority. So I will say STP priority, STP priority, and then put the question mark. And you can see the bridge priority in steps of 4096. That means this value should be the multiplier factor of 4096. In the steps, that means the increment of 4096. So I will say, okay, fine. Set the priority, the lowest priority, which is 4096. And that's it. And then the priority of switch B will say STP priority, for example, 8192, and that's it. And I'm not going to change the priority of C. I will let it as default priority. So now you need to check the status. So again, I will give the same command, display STP brief. Now you guys can see the status of the ports, the roles of the ports of switch A has been changed. Both are acting as the designated ports. That means switch A has been elected as the root bridge. And you will see this port, now this port will be in the block state, in the discarding state. Let me show you. Display STP brief, and you guys can see this port number 3 of switch C, STP has put that port into the alternate in the block state, the discarding state. So now in our topology, this is our root bridge, or you can say this is our primary root, and this is our secondary root bridge, and this is our non-root bridge. Is that clear to everyone? So that's how we play with the priorities. That's how we play with the priorities. And that was step number 1. That was step number 1. Now, then comes step 2. Okay.
Please, I have a question.
Yes, yes.
We should have one designated port on each switch, right? Or it shouldn't be?
I didn't get you.
I mean, at least we have to have one designated port, or it's not necessary for each route, each switch.
I still didn't get you. But
I mean,
yeah.
at least for bridge route, for switch, primary switch, we have to have designated routes, right? On designated route. For other non-route bridge, we should have at least one route port, right?
Yes, yes, obviously. Why this should be? Because in my design, this is the standard design. These are the distribution switches, and this is the access layer switch. This is the access layer switch. So obviously, if this if STP do not put this interface in the block state, then obviously there will be a loop. There will be a loop. So this is a closed path. So that's why there should be a non-root bridge, and one of the interface of the non-root bridge will be in the block state. Otherwise, you can see the loop is occurring in this topology. So we are discussing STA, spanning tree algorithm, and we have done with the first step, and that was you need to select root bridge per network. And the second step is really very important. If you understand this, you will get the STA. But If you don't understand the second step, you will be in trouble. So we need to figure it out, the designated port per segment, the designated port per segment. In our network, now we have this kind of infrastructure. For example, we have 3 switches, and this switch A has been elected as the root bridge, and we can say the rest of the switches are non-root bridges, Switch B and switch C both are non-root bridges. Just take this example. So in this network, how many segments we have? As we have discussed earlier, this is segment 1, this is segment 2, and this is our segment 3. And the port number 1 is connected with port number 1, the port number 2 is connected with port number 2, and the port number 3 is connected with port number 3. So he says that find out the DP, the designated port per segment. That means I'm having 3 segments in my network, segment 1, segment 2, segment 3. That means there should be 3 DPs. That means in one segment, there should be one DP, one designated port. In one segment, for example, this is segment 1. In this segment, there should be one designated port. But again, there are 2 candidates. There are 2 candidates to be elected as a designated port. This port says, I want to be the designated port, and this port of the same segment is also the candidate to be elected as a designated port. But who should be the designated port? Again, we need to conduct an election. But how this happens and who is the designated port? He says designated port is the port which transfer or transmit best BPDU. Designated port is such a port which transmit the best BPDU. Obviously, there are always 2 options, the best and the worst, superior or inferior, good and a bad. So we need to figure it out from both of the ports who is going to be transmit the best BPDU. But now the question is, sir, what is BPDU? What is BPDU? So what is BPDU? BPDU is a bridge protocol data unit. What is BPDU? BPDU is a bridge protocol data unit. And what is inside the bridge protocol data unit? So we can see clearly this is data unit. That means it will be having something inside this packet in this unit. So what is inside the BPDU? This is really interesting. And this is the key point of second step. If you get successful to understand the BPDU, then the STP algorithm is just a piece of cake. But if you don't understand what is inside the BPDU and how elections are conducted, when we talk about the designated port, then you will face yourself in the trouble. So you need to be focused and you need to be tuned. Sure, I have already given permission to many students. So Merna. I guess I can permit only, okay, Merna Ahmad Farid, I have allowed you the permission. You are appearing 2 times. So the second step is we need to figure it out the designated ports per segments, and I'm having 3 segments. That means in each segment there would be a 1 DP. In each segment there would be a 1 DP. And now the question is, what is DP? Who is designated port? It says such a port which transmits the best BPDU. And now the question raised, so what is BPDU? And I'm saying BPDU is a bridge protocol data unit, but this is not sufficient to tell the abbreviation. That means we need to look into the BPDU, what is inside the BPDU. So let's start. Whenever you extract the BPDU packet, you will get 4 things. You will get 4 things. 4 things mean 4 fields. 4 fields inside the BPDU. The first thing is the first thing is root bridge priority. Root bridge ID. You can say root bridge ID. And the root bridge ID consists in 2 things. First, as we have seen, we can check the priority, or otherwise we can check the MAC address. So the first field inside the BPDU is the root bridge ID, and the root bridge ID consists on 2 things. First one is the priority and the second one is the MAC address. Okay, fine. Then the second field is cost to the root. Cost to the root. Because already we have selected the root bridge, so we know this attributes. And cost to the root means, for example, I'm having this kind of connectivity, and this is our root bridge. And right now, if I'm sitting over here at switch C, so something is going to be transmitted from this port, or I'm receiving something from the root bridge over here. So I will start in the reverse case to check the cost of the link. So every vendors have different cost links. For example, whenever we talk about the gig interfaces, it has the cost like 4, 4, and 4 over here. So if I'm receiving something over here and I'm receiving that packet from the root bridge, so obviously it is traveling, if it is traveling in this direction, in anti-clockwise direction, and I'm getting this by sitting over here. So to calculate the cost, I will start in the reverse path. So I will check what is the cost to the root, the point where I'm receiving. If I want to check the cost of the link, I will start in the reverse case. I will check the cost of the link, that is 4, and till the root bridge. So I will again, you can see there is another link. So I'm receiving that packet by 2 links, from this link and from this link. That means cost to the root would be 8. And if I'm receiving something over here, so if you need to figure it out, what is the cost to the root, you need to move in the reversible path, and you will see the cost is 4. So how many links you bump, how many links you jump? So you need to calculate the cost from where you receive the packet till to the root bridge. So the cost to the root bridge means whatever the reference point is, you need to move in the reverse path and you need to calculate the total cost, which takes you to the root bridge. So cost to the root means the reference point where you are sitting and towards, in which direction? Towards the root bridge direction. And you need to calculate the cost on all the links. So that is the mean of cost to the root. And then the third field, which is sender ID. Sender ID. Sender means who is sending that BPDU. And again, in sender ID, we will again look into two things. First thing is again the priority, and the second thing, MAC address. And the last one, is the fourth field, which is sender port ID. Sender port ID. Sender port ID. Sender port ID consists in two things. First is the port priority, and by default, every port has a default priority which is 128. Likewise, a switch, every switch has the same priority, 32,768. That was the priority of the whole switch. But whenever you talk about the priority of the port, so every port, for example, port number 1, port number 2, port number 3, every port has the same priority by default, which is 128. And then the second thing in the sender port ID is the port number. The port number. I know this is completely done yet. A few of the people are still confused what I'm writing and what I'm saying, but you will get it now very soon. Don't you worry. Just remember this sequence, the same sequence I have written over here. That means whenever we will try to write a BPDU, the first information will always be the information of your root bridge ID, or inside that information, I will be writing priority or MAC address. The second thing in the BPDU packet would be the cost to the root. Third thing, the current sender ID, that is root bridge ID, and that is the sender ID. So every time sender always not be a root bridge, it might be non-root bridge. So this is a sender ID. So in sender ID, again, you need to carry two things, priority and MAC. And the fourth field is sender port ID. We are talking about sender's port. Over here, we are talking about switch. So these are the differences you need to understand. Whenever I'm saying sender ID, that means we are talking about a switch, the whole switch. But whenever we are talking about sender port ID, that means we are talking about the port inside that particular switch. So the sender port ID consists in two things, the port priority, which is by default 128, and the sender port number. The sender port number, and port number could be different. It could be port number 1 of switch, port number 2, port number 3, because there are different ports we have in a switch. So I'm giving you 2 minutes. Write down these steps, write down these 4 fields, and keep that in your mind. And then we are going to write the BPDU packets. And it's very easy. In the beginning, you are facing this difficult, but after a few minutes, that would be very easy for you people. So I'm giving you 2 minutes. And once you're done with this, just give me a go ahead. Okay, guys, thank you. Okay. In order to write the BPDUs, we need to understand two directions. I'm splitting my network into two logical networks. I'm going to split my network into two logical networks. And why I'm splitting my network into two logical networks, this is because I will take the first direction as a clockwise direction, and the other one I will take as the anti-clockwise direction, anti-clockwise. I will know one thing, that this switch, the switch A, has been elected as over root bridge, The first step we have done. But we need to write the BPDUs. But first of all, I will start in the clockwise direction, And remember one thing, the cost of each link is 4. The cost of each link is 4. All right. And the priority of every switch is by default, this is same. So assume that we have elected this switch as a root bridge just on the basis of MAC address. That means the priority of each switch is 32,768, 32,768, and 32,768. And also, you know the port numbers, port number 1, 1, 2 with 2, and 3 with 3. And every port has the same priority. So what are the constant values? Priority of switch is constant, which is 32,768. And the priority of switch ports is constant for every switch, that is 128. And the rest things are different. Okay. Obviously, if this is the root bridge will generate the BPDUs, from both of the ports. It will generate the BPDUs from here, from port number 1, and also it will generate the from port number 2. So first time I'm going to move as a clockwise. What I'm setting the direction as a clockwise. So I will start from here. And what was the step? Our step was you have to figure out designated port per segment. And what was the definition of designated port? Such a port which transmit best BPDUs, So we will only focus on the transmission. We will not be focusing on the receiving side. We are only interested in the transmitting. So you guys can see, if I move in the clockwise direction, the first BPDU will be transmitted from port number 1. I'm just giving it name as B1, the BPDU 1. Then the BPDU which is transmitted from this port, that port will be receiving that BPDU. But right now, I'm not interested at the receiving side. I'm only interested in the transmission side. So switch B will receive that BPDUs and then transmit that BPDU from his own port, which is port number 3. I'm just giving it name as B2, the BPDU 2. And then the same BPDU, this switch C will receive that BPDU from port number 3, but we are not interested at receiving side. I'm not interested at receiving side. These are the receiving sides. I'm only interested in the transmission side, on the transmission side. So obviously the BPDU packet that received by switch C from port number 3 it will again transmit that BPDU from port number 2 of the same switch. So I'm giving it name as B3. So how I moved? I moved in the clockwise direction. And what was my interested area? My interested area was transmission. So I only talked about the transmission side. I didn't talk about the receiving side. So where I'm writing R, that means these are the receiving ports. I'm not interested in the receiving ports. I'm only interested in the transmission ports. So the BPDU, which is generated by the root bridge, is transmitted through this port, the port number 1 of switch A. I call it as B1, BPDU 1. Then switch B receives the same BPDU and again transmit the same BPDU from port number 3. I'm giving the name as B2. And the same switch received by switch C transmitted that BPDU from port number 2. I'm just giving it name as B3. I hope class is with me. Are you guys with me?
Yes, yes, Udaya.
Yes, sir.
Okay.
Yes, yes.
Now I want to move in anti-clockwise direction. I will start from switch A again because this is our root bridge, and I will move in anti-clockwise direction. Or again, my interested area is transmission. I'm not talking about receiving because in second step, we only talk about the transmission side. So obviously, root bridge is the mastermind of STP. It will transmit BPDUs from both of the ports. So we have moved in the clockwise direction. Now we have to move in this direction, So keep an eye. In anti-clockwise direction, one BPDU from the root bridge will be transmitted through this port, and this is your port number 2. And I'm giving it name as B3 dash, the opposite name. I have written B3 over here. Now I'm writing B3 dash over here. And again, this is your receiving side. I'm not interested in the receiving side. Then the BPDU, which switch C will be receiving from port number 2, again, it will transmit that BPDU from port number 3. And I will call it as B2, the second BPDU. And again, this is the receiving port, the same port, port number 3. And if it can receive the BPDU, obviously it will be transmitting the same BPDU from this port. This is your port number 1. And for example, call it as B1 dash. And now this is the time to combine these two logical diagrams. Because this is overall, this is a one diagram, but why we are splitting into two logical diagrams? Because we want to understand the directions, the clockwise and the anti-clockwise. So if you combine them, what you will get? You will get the result. And let me draw the complete diagram. This is over switch A, this is over switch B. Both are connected with port number 1 with port number 1. And the port number 2 with port number 2. This is over switch C, and this is over port number 3 and 3. Now guys, combine them together. When I was start moving in a clockwise direction, as I mentioned, B1 is transmitted through this port, but now look at this diagram. From here is also transmitting B1 dash. Take this segment, the segment 2, and take this segment, segment 2. You guys can see B3 dash from here and B3 dash from here. So you can combine them, B3 dash, and from here that was B3. And the segment 3, the last segment, So you guys can see from here, from this port, this is B2, this is B2, and from here, that was I guess that was B2 dash, and this is your B2. Yes, guys, any question till yet? I just combined these two logical diagrams into the single one. And the cost of each link is 4, the 4 and the 4. And just keep remember, this is over root bridge. Is that clear to everyone?
Yes, sir.
Okay, now it's the time to write the BPDU. It's time to write the BPDU. First of all, I need to write these two BPDUs, B1 and B1 dash. And what we are doing actually, we are following the step number 2, and step number 2 was select the designated port per segment. We need to figure out the designated port in each segment, and we are taking this segment which we called as segment 1. In segment 1, there are two candidates, the port number 1 which is transmitting B1 and the port number 1 which is transmitting B1 dash. Both wants to be elected as a designated port, but the condition is there should be one DP in one segment. So I cannot select them both as a designated port. So we are going to conduct an election. We are going to conduct an election. And how we will conduct the election, he says, check which port transmit, which port transmit the best BPDU, which port transmit the best BPDU. So that's why I'm going B packets which is transmitted through this port and this port, and once I write the both BPDUs, I will compare the both BPDUs and I will check which is the best one and which is the worst one, which is the superior and which is the inferior. So that's why I'm going to write B1 and B1 dash. But how to write the BPDUs? We are going to write now. Okay, I have told you BPDU contains 4 fields, and I have told you to remember the sequence. Can you please tell me what was field? What was
bridge root ID,
bridge root ID? And what was inside the root bridge ID?
Priority and MAC address.
Perfect, perfect. So who is over root bridge? He's over root bridge. And what's the priority of our root bridge? 32,768. And what's the MAC of a root bridge? The MAC address is, for example, A. So I have written the first field. Then you need to write the second field. And guys, tell me, what was the second field?
the cost to root bridge.
Cost of the
Or
root.
bridge root.
Perfect. Cost to the root bridge. So right now, where I am standing right now, at the root, that means the cost would be 0. Obviously, whenever you book an Uber car or a taxi, and if you are standing in front of the taxi, and you ask him, take me to that destination, so when you reach at your destination, then you pay the fare, then you pay the cost. But if you are standing in front of the taxi and he's not taking you to the destination and he asks for you the cost, obviously you will say, why I should pay you the fare? Because you didn't take me to the destination. So right now you are standing at the root bridge. You didn't cross the link. So that means your cost is 0. Cost to the root means just turn and go to the root bridge, but you will see you are still at the root bridge. That means no cost, 0 cost. In this case, the cost is 0. And what was the third field?
Sender ID.
Sender ID. Right now, who is sending that BPDU? Who is sending the BPDU? The same, the root bridge? Right now, he is sending the BPDU. That means, again, you need to write the same information of the root bridge. For example, 32,768 and the MAC address of the sender. And the last and the fourth field, what was that?
Sender port ID.
Sender port.
And what is inside the sender port ID? The port
The
period
reality of the port
Priority
128
and
128
number of interface.
and sender port number, that is 1, and you will write 1 over here. Guys, that's how we write BPDUs. But this is bit longer. This is bit longer. Why this is bit longer? Because I know by default every switch has the same priority and every port of the switch has the same priority. So I don't need to write again and again. I don't need to write this again and again. I not need to write this again and again. So we can shrink, we can reduce over BPDU. And how we can shrink that? Obviously, I'm writing B1 again by shrinking it. Instead of writing the priority, I will simply write the MAC address of the root bridge. Then I will write cost. Then again, instead of writing the priority, I will simply write the MAC address of the sender. And instead of writing the port priority, I will simply write the port number because they might change. They might change. So that's how we write BPDUs. But we have simply written B1. We didn't write B1 dash. Now it's time to write B1 dash. B1 dash. Now this is interesting. This is interesting. Okay, guys, tell me the first field. What should I read?
The MAC address. B.
Just close your eyes and blindly write the information of root bridge in the first field. In the first field, you always need to write the root bridge information. And that's what we have figured out in our first step. So we know who is the root bridge and what is the MAC address of the root bridge or what is the priority of root bridge. So in every BPDUs, doesn't matter you are writing B3, B2, B2 dash, whatever you are writing, just close your eyes and just write the information of your root bridge. And that is A. That is A. I'm not writing the priority, I'm simply writing the MAC address of the root bridge. Then
Cross to root bridge, which is 4.
that was the game. That's what I wanted to see. Anyone else, please? What was the second field? The second field was cos to the root. Cos to the root. Where I'm standing right now, I'm standing right now over here because we are talking about B1 dash. We are talking about this one. And cos to the root means you can see this packet we are transmitting from here. So from where did you receive? If you are transmitting, that means you have received that BPDU from somewhere. And if you are transmitting this BPDU, that means root bridge have sent it to you. But root bridge doesn't send it to you by this way. You need to change, you need to reverse, you need to inverse your path. I will start moving in the backward direction, in the backward direction. In the backward direction to the root. That is the meaning of cos to the root. Just look at the direction of this BP here. But just figure it out from where you are receiving that BPDU which you are transmitting right now. Obviously, you need to move in the anti-clockwise direction, the backward direction. You need to adopt the reverse path. And you will see, you have covered that link. The cost was 4. And again, we need to move towards the root. Again, you have another link which costs you 4. That means the total cost of that BPDU would be 4 plus 4, that would be 8. Guys, are you with me at this point? This is very interesting and important point. So, cost to the root means just focus on the direction. And when you focus on the direction, you need to move back to the root bridge. So the 4 plus 4 would be 8. So the cost is 8. And then, guys, what was the third field? What was the third field?
Sender ID.
Sender ID. Just tell me, who is sending, who is transmitting this BPDU right now? Who is the sender? Who is the sender right now? Yes, guys. Who is the sender right now?
B.
Yes, exactly B. You can see over here.
Yes.
This switch B is transmitting this B1 dash right now. So the sender ID means the sender priority or the sender MAC address, but we are not going to write the sender priority because by default all are having the same priority. So I'm going to write only the MAC address. And then the sender port number, sender port ID, and in port ID, there are two things, port priority, but we are not going to write the port priority because every port has the same priority. So I'm going to write only port number. And right now sender port number is 1. So that's why I'm writing 1 over here. So now we have successfully write 2 BPDUs. B1, which was transmitted by the root bridge, and B1 dash. Currently, this BPDU is transmitted by switch B, that is B1 dash. Now, you have to compare both BPDUs and you need to figure it out which one is superior and which one is inferior and which one is the best and which one is the worst. So you need to figure it out. So how will you figure out? Tell me, who will win the election, B1 or B1 dash?
B1 will be designated route.
Okay. The rest, guys, I'm waiting for your response.
I think
B1, I think.
B1.
Why you are not sure? Why do you think?
Cost less.
Okay, fine. You are absolutely right. How we can distinguish between best and the worst and the superior or inferior? You can see the first field is same for both. Okay, election. When you will compare the second field, you will figure it out. This cost has lowest and this is for the great cost. So the lowest value always win in switching. So it has 0 cost, it will win the election, and this port, the port number 1, would be elected as a designated port. And that's how we select the designated port in a particular segment. Are you guys with me? And this is really very interesting. Nobody will tell you right this way. Okay, now it's your turn. It's your turn. Just keep tight. Everyone should participate in videos, and whoever is interested in to understand the STP, take the pages and any ballpoint, and you need to write B3 dash and B3. You need to write these two BPDUs and send it to me on the chat box. And you have to write like this way: B3 dash and then BPDU, and B3 then BPDU. You need to write both of the BPDUs at once. Okay, so I'm just waiting for all the participants to write BPDUs, B3 and B3 dash. Okay, let's start. Now you need to write both simultaneously. Okay, marked B3 dash. Okay, I got 2 replies only. Just waiting for the rest of the guys. You are absolutely right, but let other people. Yusuf Al Saleh, stay with me, stay with me. So, what's the reason, Yusuf? What's the reason? Ayman Sultan, just look into it. Is it B3 or B3 dash? Okay, okay, fine, fine. Mohammed, perfect. Perfect. Okay, that's all, guys. Okay, so most of the people are absolutely right. So what about the B3 dash? Obviously, the first field was about the root bridge ID, and that is A. And what about the cost? Because right now you are sitting at the root bridge, so the cost is 0. And who is the sender right now? The same sender, the root bridge, again A. And from which port? From port number 2. So that is B3 dash. Fine. Then B3, you are talking about this BPDU. So who is the root bridge? I told you root bridge is always the same in every BPDU packet. And what is the cost? You are transmitting this BPDU right now from here. And just revert your direction, just reverse your path and go to the root bridge and check how many links you found in your way. So 2 links meant 2 cost 2 times, that means the cost is 8. And then who is the sender? Right now, this BPDU is transmitted by C. That means this would be C. And then by which port? From port number 2. And now you need to check who is the best and who is the worst. So obviously, again, if you look at the cost, this has the lowest cost. That means it will elect the election, win the election, and this port will be selected as the designated port. So we have done with 2 segments, with segment 1 and with segment 3, for example. And still we have one segment, which was segment 2. So guys, be ready to write B2 and B2 dash. B2 and B2 dash. This one, this is over B2. And for example, this is over B2 dash. Just write it quickly. This is B2 dash and this is over B2. Kemal, excellent. Come on, guys. Nawaf. Absolutely wrong. Ayman Sultan, what happened with you? Why you are putting C? The first field is always about the root bridge. So what is C doing over here? And Nawaf B. Why B? Because our root bridge is A. So why are people putting B and C? Okay, guys, thank you so much for your cooperation. Let me write it for the people who is not still clear with that concept. So I need to clear this portion so that we can write clearly over here. So we need to write B2 and B2 dash. All right. So just look at B2. This is over B2, which is transmitted through switch B from this port. So the first information is always about your root bridge ID. This is your root bridge ID, guys. So what's the MAC address of the root bridge? That is A. Why you are writing B and C instead of writing A? The first field is always about the root bridge and then cost to the root. Guys, you can see this BPDU is transmitted through this port. That means you need to go back. From here, you need to go back to the root. And you can see there is only one link. That means the cost is 4. And then sender ID. Who is the sender right now? B is the sender right now. B is the sender right now. So we write B over here. And from which port? From port number 3. This is quite easy now. This is quite easy. And what about B2 dash? Check this out. This is over B2 dash. This is over B2 dash. And the first is information is always about your root bridge ID. You don't need to think even. What should I write? I told you, just close your eyes and put the information of root bridge in the first field. And then you need to put the cost. So how you calculate the cost? We are sending this BPDU from over here and just go back to the root bridge and you will see there is only one link which you are crossing. That means the cost is 4. And then who is sending right now? Who is sending this BPDU? Obviously this switch, the switch C. This is switch C. And by using which port? The port 3, and this is your port number 3. But this is interesting election. Why? Because root bridge is same, so election would be in tie. Again, the cost is same, election in tie. But now it will be elected on the basis of sender MAC addresses. And now you know who has the lowest MAC address. Obviously B. B represents 11 and C represents 12. That means B2 would be your best BPDU and it will elect the election. It will win the election. That means B2 is going to be the next DP of this segment 2. So we have done with 3 segments. In segment 1, this is elected as a DP. In segment 3, this is elected as a DP. And in segment 2, this port has been elected as a DP. Done with the second step as well. So let me draw this clearly. What we have done so far, you are having 3 switches. And we have connected them by this way. Port number 1 with port number 1. Port number 2 with port number 2. Port number 3 with port number 3. That was switch A, B, and C. And these are the MAC addresses of the switches. And the cost between the links is 4. So what was the first step? First step was you need to figure out the root bridge per network. And how we did this? We conduct the election on the basis of priority. If the priority is same, by default, every switch has 32,768. If every switch has the same priority, then election will be in tie state. then we need to compare the MAC addresses, and the switch which has the lowest MAC address, the lowest MAC address will win the election, and who will the election, it will be elected as the root bridge. So in our case, switch A would be elected as a root bridge. Okay, fine. Then rest was acting as the non-root bridges, Fine, that was the first step. And what was the second step? Second step was you need to figure out designated port per segment. So how many segments we have in this network? We have 3 segments: segment 1, segment 2, and segment 3. Doesn't matter what's the sequence. So that means we have 3 segments. That means in each segment there should be 1 DP. So if we are having 3 segments, that means we will calculate 3 DPs. So in this segment, you have seen that this port elected as the designated port. And in segment 3, you have seen that between these 2 ports, this port has been elected as a designated port. And in this segment, between these 2 candidate ports, this port has been elected as a designated port. And that's what we have done in second part. And now the third step. And third step is quite easy. It's quite easy if you have understanding of BPDUs. So the third step is find out the root ports per non-root bridge. You need to figure out the root ports per non-root bridges. Now the question is, how many non-root bridges I have in my network? I have only 2 non-root bridges. So how many root ports I will be having? Definitely I will be having 2 root ports. That means in each non-root bridge, there would be one root port. And who is going to be selected as the root port? He says that which receives the best BPDU, In the second step, he was interested in the transmission. But in the third step, you can see how we have to deal. We need to check which port receives the best BPDU. It will be elected as a root port in the non-root bridge. So guys, now we are interested in the receiving side, and we are only talking about the non-root bridges. So I have 2 non-root bridges. One is over here and one is over here. And for example, if you take this non-root bridge, how many BPDUs he is receiving? Obviously, he is receiving 2 BPDUs. One from this side and one from this side. Just let me give it names. For example, I say this is B4 and this is B4 dash. So guys, you need to write B4 and B4 dash now, and you need to follow the same steps, the same fields. Okay, start it now. You need to write B4 and B4 dash, which are received by B. But the field names and the criteria is same. Okay, mark quickly. If you get successful in writing B4 and B4, that means you have understand the ST algorithm. But now if someone do the mistake, then that is not in my control. It is not ready to learn. I got only 2 replies and they are absolutely wrong as well. Again, the wrong answer. Okay. Afnan, perfect, perfect, excellent, excellent. What about Imad? Imad, no, you're wrong. Nawaf, wrong. Tevni, wrong. Muhammad,
I didn't hear you, sir. It's wrong.
sorry?
Was my answer incorrect?
Yes? Okay, I guess this is my turn. Imad. Imad, perfect. Imad, is that was you? Okay, you are perfect. You are perfect. You have written now clearly. This is fine. So, okay, look at there, guys. We need to write B4 first. B4. As I told you, the first information you can write it by closing your eyes. That is the root information, the bridge information. Then cost to the root. Most of the students doing mistake by writing the cost. Now you are receiving the BPDUs. That means you have reached at this port. That means you have crossed that link. That means you have paid the cost. You have paid the fare. You start writing from here and you have reached your destination. That means you need to pay your fare. You need to pay the cost. Now you are at receiving side, not at the transmission side. So you have reached at this interface. That means your cost is 4. And then what was the third field? The sender ID, sender. Still the same. Who is the sender? You are receiving, but he's the sender. He is the sender. The third field, what I have written, the sender, the words are same, the fields are same, the sender ID. You need to tell about the sender because right now you are receiving. So who is the sender? He is the sender. So sender ID is, that means is the sender MAC. And then the fourth, the sender port ID. Again, you need to mention the information about the sender. And by which port he is sending you? By port number 1. This is not necessarily the both ports should be same. There might be port number 1, there might be port number 5. So you won't be writing this port because the fourth field is sender port ID, sender port number. You need to mention the sender port number, not. That's how we write B4. And now this is a turn to write B4 dash, this one, B4 dash. Your focus should be on receiving side. So the first information is always same, that is A. And then the cost, obviously, again, if you think about it, if you look at this, you have reached over here. So you need to move. You need to move back towards the root bridge. How many links? 2, 4, 4 plus 8. And then again, the third field, the sender ID. You are receiving right now, but who was the sender of this video? This switch, C. And by which port? By port number 3. The port number 3. Now this should be clear to everyone. Whoever doing the mistake by writing the cost, by writing the sender, by writing the port number, I think this should be clear to everyone. Yes, guys. Especially those guys who are writing the wrong VPDUs. Now you got the point.
Inshallah, yes, sir.
Okay.
It's okay.
And who is the best? Obviously, you know, the B4 is the best one. And the understood thing is this port has already elected as a designated port. So obviously that port is understood would be elected as a root port. But I intentionally intend you to perform the election so that you can understand the concept. Yes, you can, because you need to calculate the cost, but this cost varies by the links. For example, if you are using fast Ethernet or gigabit Ethernet, so every link has different cost. In fact, every vendor has a different cost. And you can change that cost as well. So in this non-root bridge, this port has been elected as a root port. And now we have the final case, the ultimate case. Now this is again because we are having two non-node bridges in our network. So we have done with one only. So we have left another non-node bridge. So this is our non-node bridge, and this non-node bridge is receiving the BPDUs from this side and from this side as well. And I'm just giving them name as B5 and B5 dash. And guys, this is your last and least chance. Now you need to write correctly and perfectly. This is your last chance. Because right now I'm using gigabit Ethernet links between the switches, so their cost is 4. So that's why I'm just calculating the links. If there might be fast Ethernet, there might be Ethernet, there might be gig interfaces between the switches. So every interface have different costs. So right now, every link has a cost which is same, which is 4. So that's why I'm calculating the links. And it's the same thing if you calculate the links or if you calculate the integer values. But you are very quick. Um, 5. Hmm. All right. Nawaf, please. Why are you mentioning C? C is the receiver. Okay. So we didn't mention any receiver in 4 fields. We are always talk about the sender. Okay, Muhammad. B5. Muhammad, it's wrong. B5 is wrong. Now you can imagine some guys are still doing mistakes. So you need to practice this again. Okay, guys, let me write this as well because we have the shortage of time. F9, F4, A2. Perfect. Okay, guys.
Mr. Hamid,
Yes.
is it B5 dash? It has to be A dash C because C is the receiver, and the cost line is 4, and the line is 2, right?
Yes.
Why you said wrong for my answer? For by 5 dash,
What's your name?
B5 dash. Nawaf.
Nawaf. Let me see it again. You're talking about B5 dash?
Yes.
Yes, it's wrong, buddy. Let me tell you. Let me tell you. First of all, we need to write, for example, B5. This is our B5. And over here, this is B5. So first information is always same, the root bridge information. Then you need to mention the cost of, okay, fine. You are over here, you are receiving over here, and you need to move back towards the root bridge. That means this 4, the cost would be 8. And then you need to mention sender ID. Brother, sender ID. Why you people are writing C? If I'm receiving this BPDU over here, so I need to mention my sender. So who is the sender of this BPDU? This is B. This is B. And he's sending this BPDU from which port? From port number 3. That's it.
So we don't mention the receiver, just the sender.
We want to talk about the sender.
Okay.
All right.
I see.
Okay, so what about B5 dash? Obviously, the first field is always about the root bridge and the cost. Okay, move back towards the root, cost to the root, that is 4. And who is the sender? Because right now over here you are receiving. Who is your sender? Obviously, this root bridge, that means A. And by which port? From port number 2. Now, guys, who is going to win the election? Absolutely B5 dash, because it has the lowest cost. That means in this non-root bridge, this would be elected as the root port. And guys, what is left? To which port we didn't allocate any role? Yes, that one, the bad one. STP will put this port into the block state, into the alternate state, into the discarding state. These are the roles, and this is the state, discarding. To prevent from the loops, STP will put this block into the block state, and that's how STA, the algorithm of STP, works. That's how. So that was our topology. One with 1, 2 with 2, 3 with 3. This is switch A, B, C. It is elected as designated port. This has been elected as root port. Is elected as the designated port. This elected as the root port, and this one, STP, put that port into the log or into the alternate port. Afnan, the last point is we need to figure it out how STP works. So we run the algorithm in the manual way, and all the ports have their own statuses, and the port which left at the last, STP put this port into the block state. So that's how STP works. STP algorithm works. And in the beginning, someone may ask why STP don't put this into the block state, why STP don't put this port in the block state, why is putting this port in the block state. So we have run the algorithm in the manual way so that we can understand why STP putting this block into the block state. So now we understand why this port into the block state. And I have shown you. Now you guys can see again, we have already the results. At switch C, this is the root port. Have you seen that? That was the root port. And this port is an alternate. That means STP had put in the block state. And what about A? What about A? The switch A, both ports were acting as a designated port. That was a designated port. That was elected a designated port. And in switch B, you guys can see, let me show you, display STP brief. So you guys can see this port has been elected as a root port, and this one, the port number 3, has elected as the designated port. And the same results which we have discussed in manual method. So that's how STP works. Is there any question?
No, sir.
Okay. So guys, this is Asr prayer time. So I need to offer my prayer, and also you can people take a little breath, because that was very hectic, I guess, for you people, the algorithm of STP. So you should have a break. So we will be back after 25 minutes. So after 25 means at 2:40 from your side?
2:25, 2:30 on our side.
2:30 or 2:40?
No, it's now 2:05.
Okay, fine.
25 minutes, it will be 2:30.
Okay, 2:30. Thank you, guys. Assalamu alaikum, welcome back. Welcome, guys.
وعليكم السلام.
سلام هلا وسهلا.
So before the break, we were discussing STP, spanning tree protocol, and praising of STP that this is a good protocol. Also, this is a good protocol, but there are drawbacks of STP. And what are the drawbacks of STP? STP, in STP, different ports have different states. And how many states are there? There are 4 states. And what are the states? The state is, for example, the block state, or you can say the discarding state. Then there is listening, then learning, and then the forwarding state. What does that mean? That means if we have kind of topology that we have discussed before the break, and in this topology, STP this port into the block state. Okay, fine. And all the traffic is going through this interface and goes outside. All right. But what if this port, which was a root port, and it was in the forwarding state, if this link goes down, then what should happen? Tell me, guys, what should happen? Yes, guys. What's going to happen? What STP will do if this link goes down?
I think the whole operation will also go down.
Okay. No, because STP has put this port into the block state, but this is temporarily, just to prevent from the loop. That means if this link goes down, STP will get out this port from the block state into the forwarding state. And the traffic will be forwarded through this link. But before coming into the forwarding state, this port will be passing through different states, from blogging to listening. And by passing from blogging to listening, it will take 20 seconds. And then from listening to learning, it will take 15 seconds. And then from learning to forwarding, it will take again 15 seconds. And the plus 2 seconds for BPDUs. 2 seconds for BPDUs. So the total time is 52 seconds. That means for the 52 seconds, this port that was initially in the block state, and to jump into the forwarding state, it will take 52 seconds. And until it comes into the forwarding state, no data will be forwarded through this port unless it get into the forwarding state. So all the clients will feel the delay of 52 seconds. There is an interruption of 52 seconds. And this is not acceptable in the production network. In the early 90s, that delay was acceptable. But this is, guys, 2020. No one accept this huge delay in the interruption in the services. So then developers Then developers introduced another flavor of STP, that was RSTP, Rapid Spanning Tree Protocol, the rapid way of STP. All the algorithm is same, all the calculations are same they have done, but what's the difference? The difference is, let me show you some stuff if I'm having in my machine. So, okay, let's go here. So, here it is. You guys can see the states of STP, the states of STPs. Blogging, listening, learning, and forwarding. And from blocking to listening, it takes 20 seconds. From listening to learning, it takes 15 seconds. And from learning to forwarding, it takes 15 seconds. This is a delay in STP, and these are the port statuses. But what's the difference between STP and RSTP? The first thing, they changed the number of states, and some professional says there are 5 states. There are 5 states in STP, and the first state they call it as disable. So total there are 5 states in STP. But in RSTP, they reduces the states of the ports, and they reduces from 5 to 3. And the first state is discarding, then the second state is learning, and the third state is forwarding. That was the first key difference, the difference between STP and RSTP. And what is the other difference? The other difference is, keep remember one thing, the number of states reduced in RSTP. That is the first difference. The number of states reduced in RSTP. There are total 3 states and total 5 states, and some says 4 states. Okay. And the other difference is why it provides seamless transition. And what does that mean, the seamless transition? STP was taking 52 seconds. STP was taking 52 seconds in circumstances when, if this link is in the block state and this link in the forwarding state, and when this link goes down, this link takes 52 seconds to come to the forwarding state. When we are in STP. But whenever we talk RSTP, whenever we enable RSTP in all the switches, if this thing goes down seamlessly without any delay, this link comes into the forwarding state. And 52 seconds is a huge time. But what I'm saying, in RSTP, it seamlessly comes out from the discarding state and be able in the forwarding state. Seamlessly. I'm not saying 3 seconds, I'm not saying 5 seconds, I'm not saying 10 seconds. I'm saying seamlessly. That means not even 0 second, seamlessly. Why this happens? This happens just because in RSTP, they have increased the rules of the ports. In STP, there were 2 roles of the ports. One is designated port and the other was root port. There were only 2 roles of the ports. But in RSTP, there are 4 roles. There are 4 roles of the ports. 2 first are same, the designated port and the root port, but they have addition of 2 ports, which we called as the backup port and the alternate port. The backup port and the alternate port. And what does that mean? What is backup port and what is alternate port? Okay, we know what is DP, we know what is RP, but what is backup port and what is alternate port? For example, let me take this scenario. For example, we have three switches. This switch is the root bridge, and the both ports are acting as a designated port over here. And these are the non-root bridges, but the ports are root ports. And this is the DP again, and these two ports are in the block state. Why two ports are in the block state? Because if you see at this diagram, how many loops will occur in this topology? How many loops? Can you please tell me how many loops will be created in this topology? How many loops? And this is the shared medium. All our switches are connected through this. You may say this is your switch. How many loops will occur in this topology? No, wrong.
3.
Absolutely right. 3. How? You can see this is the one way of occurring a loop, the first one. And then this way, this is the second way. This is the second way, the blue one. And then this is the third way. So in order to prevent from the loops, these two ports will be in the block state. But in RSTP, instead of putting it to the block state, RSTP calculates the first best DP, the first best DP. And it also calculates the second best DP, the second best DP. For example, like we have, if we have a plan and we want that plan to be successful, so normally we have another solution for that plan. For example, someone says, okay, we will follow plan A. If plan A fails, immediately we will start following plan B. So that if plan A fails, we won't be having much time to plan another plan. Okay, so the same time you design two plans, and you decide if my first plan goes fail, so I will start following the other plan. So same in RSTP, it calculates the first best DP, but at the same time it also calculates the second best DP. For what purpose? For the purpose if the first DP goes down, I will immediately put the second best DP into the forwarding state. And if the second best DP resides in the same switch, where is the first best DP, then we call it as backup port. Then we call it as the backup port. What I'm saying if the both DPs, the first best DP and the second best DP belongs to the same switch, then we call to the second best DP as an backup port. But if the second best DP belongs to another switch on the same network, but on the other switch, we call it as alternate port. So if this DP goes down, RSTP has pre-calculated the second best DP and immediately put that alt backup port into the forwarding state. So you don't feel any delay, you don't feel any interruption if your any DP goes down. So that's why RSTP is very fast. You got my point? Yes, guys.
Yeah, because
It has already pre-calculated the second way. If my first plan goes down, okay, I have another plan. So you don't feel any interruption in your services. So that's why RSCP is very fast. And then there is a problem in STP and RSTP. And what's that problem? The problem is if you have this kind of topology, and STP put that port into the block state, that means this is my access layer switch. There might be 100 of end users, there might be 200 of end users, and there might be number of VLANs. Number of VLANs mean there might be 25 VLANs or 26 VLANs. So what's going to happen? All the VLAN traffic will be passing by this way, and STP has put in this interface into the block state. That means all the burden of the traffic is on the single link, and this link is in the rest state because this is our backup. We are not using this distribution switch, which is our the redundant switch. This is our backup. So normally we place one switch, but why we are using two switches over here? Because we want redundancy. We want redundancy in our network. But what I'm doing over here? I'm putting all the burden on a single link, and this is my backup link, and it will be acting on the forwarding state if something happened to this link. Otherwise, it will be on the rest. It's just like same. You have a big company, you have a big organization, and into that organization, you have two generators. Why you are having two generators? Because in the case of failure, if something happens to this generator, you need a backup. Okay, fine. But what you are doing, you are putting 100% load into the first generator because this is your backup. The second generator is your backup. It's a good way or a bad way, guys? Obviously, it's a bad way. So what should be the best way? What should be the best way? Yes, distribution. You need to distribute the load onto the both generators. You may divide 50% load on the first generator and 50% load on the second generator so that you can utilize both of the resources. Then if something happened to the first generator, okay, fine, then you can put the 100% load onto the other generator and you will troubleshoot, you will fix this out, and again you will put the 50% load balance. Because you have invested a lot of amount, it may charge you thousands of dollars. So you need to utilize the both resources. So that was a non-technical example, the lame example. Why? Because the same thing we are doing over here. This is our distribution switches. It may cost you thousands of dollars, but you are not using, you are just putting it into the backup state. So what we need to do, we need to perform load balancing. I want, if I am having 26 VLANs, the traffic of 13 VLANs should pass this, should use this path, and the remaining 13 VLANs should use this path. I want to perform load balancing, but this cannot be happen by using STP and RSTP. And this is called common STP. Common STP. common spanning tree. Why we call it common? Because for all the VLANs, this link we are using and this link is in the block state. That behavior is called common STP. And this is not a good thing. And the load balancing which you want to perform is cannot be done by two flavors. So we need another flavor of STP that is called MSTP, multi-spanning tree protocol, multi-instance spanning tree protocol, and some vendor says MST and some vendor says MSTI. Don't bother yourselves. So this is multi-instance spanning tree protocol, multi-instance. And why we call it as multi-instance? Let's have a look. For example, still having the same topology because this is the triangle, and in the production network, this is very famous topology. So we have switch A, we have switch B, and we have switch C. And over here, for example, I have 20 VLANs in my department. I have 20 VLANs. So if I'm using common STP, that means all the traffic will be using this link and this link will be in the block state, in the backup state. Okay, fine, but I don't want to use this. Your company says, because you are a network administrator, I want to perform load balancing. I want to utilize my both of resources. So what you need to do, you will run MSTP. You will run MSTP. And what we can do by running MSTP, we simply create, because its name is multi-instance. Its name is multi-instance spanning tree protocol, multi-instance. That means I can create multiple instances. For example, my requirement is I want first 10 VLANs from 1 to 10 use this link, and this switch should act as a primary root bridge, for first 10 VLANs. And from 11 to 20, this link and this switch should act as a primary root bridge. What does that mean? Does that mean if this link goes down, that means all the traffic of VLAN 1 to 10 will be interrupted? No. As a backup, VLAN 1 to 10, the traffic of VLAN 1 to 10 will use this link if this link goes down. That means, listen it very carefully, that means for VLAN 1 to 10, this switch will be acting as a secondary root bridge, In the same case for them, if this thing goes down, what does that mean? That the traffic of VLAN 11 to 20 will be interrupted? No. As a backup, the traffic of VLAN 11 to 20, this switch will be acting as a secondary root bridge for all the VLANs. You guys can catch me? You got my point? What we are trying to do, we are simply achieving load balancing. By using MSTP, which cannot be offered by STP and RSTP. So what we need to do, in order to do that, we need to create instances. I will create first instance. I will call it as instance 1. And I will map VLANs from 1 to 10 with instance 1. And I will create another instance 2. And I will map instance 2 with VLAN 11 to 20. So I need to create 2 instances You can create so many as you want, but the requirement is if I'm having 20 VLANs, I can create 2 instances. So I can divide the loads on both of the links, 50% VLANs traffic from this link and 50% traffic of VLANs from this link. So what do we need to do? We need to create 2 instances and we need to map these instances with the VLANs. And what I will do, I will change the priority of this switch. For instance 1, I will set this switch as a primary root bridge, and for instance 2, I will set it as secondary root bridge. And over here, I will call instance 2 and I will set primary root bridge to instance 2, and I will call instance 1 and I will set this switch as a secondary root bridge. I hope this is clear to everyone. If it is not clear, you can ask. Feel free to ask. Yes, guys.
It's clear, Mister.
So how we do that? How do we do that? We need to perform a lab, that how can we create instances and how we can change the priority for the instances. And whenever I will calling an instance, that means I'm calling this particular VLANs. If I'm calling instance 2, that means I'm calling VLAN 10 to 20. And for them, at switch A, I will set them as a primary root bridge for instance 1. And what is inside the instance 1? The VLAN from 1 to 10. And if I'm calling instance 2, that means I'm calling these VLANs. And for them, I will set this switch as the secondary root bridge, the alternate way, the alternate path. And same goes over here. But to do that, we need to configure journal configurations. And what are the journal configurations we need to perform first? And these are, for example, if I'm accessing this switch, we'll change the mode of STP. For example, STP mode, and I'm putting the question mark. You can see I can run any flavor of STP. So by default in Huawei, this is RSTP, but you can go with STP and you can go with MSTP. So you need to change the mode first. You need to change the mode, STP mode, MST. So you need to change this mode on all the switches, because on all the switches I want to run MSTP. So the STP mode MSTP. The STP mode MSTP. And at switch C, I will change the mode STP mode MSTP. So that was the first step. You need to change the mode. You need to change the flavor of STP into MSTP. That was the first journal configurations that you need to perform on all the switches. Okay. Then again at A, I will say STP regional configurations. You need to configure a region, and in that region you will set any name. For example, I'm setting Huawei and the region level. It could be any integer value. So you need to configure the domain by name Huawei, and you need to configure any integer value for that group. And you need to create 2 instances. For example, I will create instance 1 and I will map I will map any number of VLANs. For example, I'm going to map from VLAN 2 to 10 with instance 1. Then I will create another instance, for example, instance 2, and I will map them with VLANs from 11 to 20. And then I will activate these regional configurations, and that's it. And what we have done, let me show you again by giving this command, display this. You can see I have done these configurations. I have configured the name, I have configured the number, and then I have created two instances. I'm mapping instance 1 with VLANs 2 to 10. I'm mapping instance 2 with VLAN 11 to 20. And I'm activating regional configurations. And I need to do the same configurations on all the switches, But let me create VLANs first. I didn't create any VLANs. So VLAN batch from 2 to 20. Because there is already VLAN 1. So you don't need to create VLAN 1. So that's why I'm creating from VLAN 2 to 20. So you will create all the VLANs, the same VLANs on all the switches. So let me quickly create the VLANs on all the switches by giving this command. And then you need to do these configurations on all the switches. I'm just copying this because the region name should be same. The number should be same on all the switches. In fact, this is case sensitive. If you write Huawei in the capital letters and on the other switch, you write this name in the small letters, you cannot see the results. Okay, so you need to configure same things on all the switches. That's why I'm copying this and I'm pasting on all the switches. So the same configurations I'm pasting on all the switches. And the last thing we need to do, I will go to switch A because I want the traffic of VLAN 2 to 10 should prior this link, and this switch should act as a primary for these VLANs. And this switch should act as a secondary for VLAN 11 to 20. So how we can do that? This is very simple. So you will say STP instance, which instance I'm calling instance 1. And whenever I will call instance 1, which VLANs are going to map is calling 2 to 10. So I'm saying STP instance and priority. And I need to, or you can say instance 1 root primary. Instead of writing the priorities, you can play with the words. So what I'm saying for instance 1, please be a root primary root bridge. And now I'm calling instance 2. And for instance 2, I'm requesting him to be a root secondary. And that's it. Only two commands. Which commands? These commands. STP instance 1, I'm calling instance 1, and when I will call instance 1, that means we are calling VLAN 2 to 10, and for them I'm saying to switch A to be a root primary, and for instance 2, that means for VLAN 11 to 20 be a secondary root bridge. And the opposite thing I need to configure on switch B. Why? Because I want this switch should be primary for the VLANs 11 to 20 and should be configured as secondary for VLAN 2 to 10. So how can we achieve that? We'll simply say STP and instance. I'm calling instance 2 first because I want them as primary for instance 2 for VLAN 11 to 20. And then I will say STP instance 1. I'm calling instance 1. And whenever I call instance 1, that means I'm calling VLAN 2 to 2 to 10, and I will set for that VLANs this switch as a root secondary. And guys, that's it. Now you can perform the load balancing. How we can the proof? Okay, just go to the switch C and just give this command: display STP instance 1 brief. I want to check my instance 1, and now this is very interesting result. So he says display STP instance and no instance is information is available. Although we have triggered, but whenever we try to configure the previous the old topology, it don't show us the results because we are using simulator. It does not happen in the real devices. But if I remove this topology and I will be creating the new topology, you will be able to see the results, because I can show you we have created the multiple instances. So display MSTP STP regional configurations. So you guys can see we have created instances, but he's saying no instance information is available just because we are using simulators. So normally some of the concepts are not we can verify. But if I remove this topology and I will create another topology, the new topology, you will be able to see the results. And here you can see I have created instance 1, and I have mapped these VLANs with instance 1, and I have created instance 2, and I have mapped these VLANs with instance 2. And by default, there is MSTI 0, instance 0, and all the VLANs are mapped into instance 0. Okay, so we have done all the configurations, but we are not able to see the results. But you can do it at your own. If you start the topology from the beginning, you will be able to see the result. I have a lot of things to do. Otherwise, we can start the topology again and we can configure this again. No problem. But the results would be same. The results would be same, which we have discussed. So you can create a new topology and you can run these commands again, and you will be able to see the results if something is not wrong with the simulators. So again, this is simulator, this is a software. So normally some of the results we are not able to see. We are not able to see in the simulator. Okay. So let me check it again if now I can see the results or not. So we need to do the configurations again. Okay, so we have activated the regional configuration on all the switches. So nothing wrong with the activation. So switch 6 and then 7 and then 8. So let me rename them switch A, and then system view sysname B, and then so what we are going to do, we are going to create VLAN batch from 2 to 20, and I need to do the same configurations on all the switches. So get the same VLANs over here and the same VLANs over here, and still I'm not sure it will show you the results or not. So STP mode MSTP, you need to enable MSTP on all the switches. Yes, Nawaf, I have given the name. So STP mode MSTP, and again MSTP STP mode MSTP. Okay, fine. Then we need to configure few things. STP regional configurations or region name, for example, it's Huawei, and region level, for example, 12, instance 1, VLAN 2 to 20, instance 2, VLAN 11 to
122 is to 10.
into instance 1. Okay, so instance 1 VLAN 2 to 10, and then 2 and map with VLAN 11 to 20, and we need to activate the regional configurations. All right. So display this so that I can copy all these commands. So I'm copying all the commands, copy and just paste them over here. So, okay, fine. We don't even know what is over root bridge. So the results might be different because in the last topology, we know what was the root bridge and what port was in the block state. So we don't really know who is going to be the root bridge right now. Okay. So this, and then pasting it over here. Right. So we don't really know who is the root bridge. So how we can figure it out? So display STP brief. So again, this is in the block state. Okay, so we cannot verify the results unless yes, I have changed the mode, STP mode, MSTP, but we didn't configure the priorities. All right, we didn't configure the priorities. So STP, I want this switch as a root bridge so that we would be able to see the result. STP priority 4096, and I want this switch as non-root bridge. Okay, fine, no problem with that. So STP priority 8192. Okay, then I will change the priority for the instances. So I will call STP instance. Let me show if this should be the port number 3 should be in the block state. So display STP brief. Yes, you guys can see now this port in the block state, and this switch will be the root bridge. Display STP brief. So the both ports are in the designated ports. That means this port, this switch has been selected as a root bridge. So we have achieved the same results. And now what we want, we need to configure this switch, the STP instance 1. I'm calling instance 1, and I want to change the priority as a primary root bridge, primary root, or root primary, a root primary for instance 1, and STP instance 2, and I want this as the root secondary. Okay, fine. And on switch B, calling STP instance 2, and I will set it as root primary. And STP instance 1 as root secondary. All right. I have done the same configurations again. Now see if we can see the results. So display STP instance. Okay, what other I can put? Any instance number? No instance information. So we cannot see the results in the simulator because we have done 2 times, but he's saying no instance information is available. Although we can see display STP regional configurations. We have created an instances, and he's showing us the mapping the instances with VLANs, but still he's saying there is no information related to instances. That means you cannot verify the results in this simulator. But if you are having 3 physical devices, okay, if you do the same lab, you will get the results. You will get the results, okay, because we are pretty sure about this. Normally, we provide trainings on the real labs, but because this is a virtual class, so I'm using the ENSP, but you cannot see the results. You cannot see the impact of MSTP in the simulator. Okay, guys, so far so good. But you should, yes, yes.
Mr. Hamid, I have a question. You said display STB. What do you mean STB? You mean the mode?
This one, this display STP.
STB. Yes.
Normally, if we want to verify the MSTP configurations, so normally we don't write MSTP or RSTP. All the time we will write STP, but inside that we have running MSTP. So automatically the operating system of this device will show you the configurations about the RSTP. I know we have created these instances in MSTP. We haven't created this in STP. So it's a command. So you guys can see we have changed the mode. STP mode, RSTP, MSTP. We have set that mode. But
Okay.
whenever you want to verify anything, any configurations about the RSTP or MSTP, you will always say display STP. You will write as display STP. There is no command like display MSTP. No, you can see there are multiple commands starting from M, but you will never find any command starting with MSTP.
MSTB.
All right.
Okay. All right.
Okay, guys, so far so good. Is there any question related to STP, RSTP, MSTP? So you need to understand the concept. Unfortunately, we cannot see the impact of MSTP in this Huawei simulators. If someone having the real devices, you can do the same practice and you will get the results. All right. So if there is any question, you can guys let me know.
What is revision level we configured on regions?
All right. So whenever you want this kind of load balancing and something, so you need to configure a domain. You need to configure a domain that which switches are going to be the part of MSTP. For example, I set the name as Huawei. You can write any name and you set the integer value. Why we are using this? Because if someone tried to connect with my switch, if someone try to connect with my switch, it might be hacker, it might be an unauthorized person. If it has not been configured the same name and has not been set at the same integer value, it cannot get any traffic of any VLANs until unless he does not join the same domain. So we configure domain and the VN number so that no external switch would be able to join this domain until unless he configure the same parameters. All right. So this is for the security purposes, so that any other person, any unauthorized person wouldn't be able to join this domain. So if I'm having another switch, over here, and I don't want to run MSTP on that switch, so definitely I won't configure these name and VN number on that switch. So this switch, although this is a part of our network, but nothing is related to MSTP inside that switch because we didn't configure any domain and any number over here. All right. So switches, all the switches, to them we want to make a part of our domain. We configure the same parameters on all the switches. Although we are having multiple switches in the same network, but we don't configure these parameters on that switch, that means he's not the part of MSTP. We don't want to run MSTP on that switch. You got my point? So these parameters makes unique to your domain, and that's it.
Yes, clear. Thanks.
Okay, guys, we are going to start another topic, but this is the time of Maghrib prayer. Just give me a few minutes and I will be back right after 10 minutes. I will be back right after 10 minutes. And I'm going to send a link into the group. And this is the feedback form. Everyone need to fill this feedback form and you need to submit. There are some few questions and you need to fill the answer of these questions, and at the end you will see a submit button, and then you will press this button after the submission. All right, so I'm going to send a link. You will open that link and you will fill that form, and then you will press the submit button. Clear? And everyone have to do that.
It's clear. Okay, we'll do it.
Okay, I will be back after 10 minutes, inshallah. Assalamu alaikum, welcome back, guys. Yes, everyone have submitted the form. Am I right?
For me, I did.
I got the reply from 2%. What about the rest? Okay, let's start another topic, which is lag, link aggregation group. Link aggregation group. We have seen that if you are having two switches, for example, switch A and switch B, and if you are using one link as a trunk between the switch to pass multiple VLANs traffic, and that was a single point of failure, then we tried to add two or more links, for example, two or three physical interfaces. But what was the behavior of STP? STP was putting these interfaces into the block state. And this single interface, the single trunk, wasn't sufficient to pass all the traffic of my all VLANs. For example, this link has the capacity of 10 megabit per second. And here I'm having one VLAN, for example, VLAN 2. And inside this VLAN, I'm having 10 users. I am having 10 users. And to each user, I have dedicated 1 megabit per second. So if I have assigned 1 MB to each user, and while I'm having 10 users, that means the traffic of 10 user would be 10 megabit per second. And this is exceptional case. Okay, the link carrying capacity is 10 megabit per second and the volume of the traffic is 10 megabit per second. Okay, fine. But what if I need to add another VLAN, for example, VLAN 3, and again in VLAN 3, I have 10 users. I have 10 users, and to each user, I have assigned dedicated bandwidth, which is 1 megabit per second. That means again, the volume of the data of 10 users would be 10 megabit per second. And now the total volume of the traffic which has to pass through this trunk would be 20 megabit per second, 20 megabit per second. But the link carrying capacity is 10 megabit per second. Under this situation, this is what we call bottleneck. What we call bottleneck. This is a bottleneck situation. That means the network will be choked because the link carrying capacity is 10 megabit per second and the traffic volume is of 20 megabit per second. This is impossible. And all the rest interfaces, STP has put them into the block state. I cannot use them. So what should be the solution? In that case, what should be the solution? That means we need to deceive STP. We need to deceive STP because if I continue to add multiple links as a backup, STP will do the same job. STP will do the same job. So what's the solution? The solution is if I'm using 4 links, and each link is offering 10 megabit per second, this link also offering 10 megabit per second, 10 megabit per second, 10 megabit per second. I have to receive STP so that STP does not put these interfaces into the block state. So what we need to do, we need to bundle them. What I will do, I will take all the physical interfaces and I will bundle them into one logical interface, Now, this is the physical diagram, what we can see. Okay, fine, there are 4 links, but what STP will see, STP will see only one link, one logical link. This is the logical diagram, and this is your physical diagram. So whenever STP see only one link, it never put that one link into the blocking state. It always put that link into the forwarding state. And what's the advantages of bundling the physical interfaces? We can aggregate the bandwidth. For example, the one link was offering 10 megabit per second. Now overall, if I bundle them in one, so the overall bandwidth would be 40 megabit per second. And if one link goes down, no problem, all the rest interfaces will be using to forward the traffic. And if second link goes down, no problem, still you have 2 interfaces. And the third link goes down, again, there will be a choking situation. So what we need to do, normally what we do, we create 2 bundles. The first bundle and the second bundle. And what STP, see, STP see only two logical interfaces. And whenever STP finds two links, it puts the one link into the forwarding state and put the other link into the blocking state. That means if my first bundle totally goes down, then I have a backup, I have another backup as a bundle. So that's the concept of link aggregation group. To aggregate the link into a group, and this group is a logical group. This group is a logical group. So we are aggregating the links. We are aggregating the links into a group so that we can use the better utilization of the bandwidth. We have better utilization of the bandwidth because we have number of VLANs over here, we have number of users over here, so we cannot rely on a single trunk. Are you guys with me?
Yes, we are with you.
Yes, sir.
All right. So the way we do that, again, we have two ways to create a bundle, to create the link aggregation group. One is the static way, and the other one is the dynamic way. And when we were talking about the routing, we were having the two methods. We can perform routing by static way, we can perform the routing by dynamic way. And right before we were talking about the STP. So again, we were having two methods. One is manual way. You can put any interface into the shutdown state, and you can again put them into the undo shutdown state. And the other one was the protocol, STP. So whenever we talk about the static way, that means we need to configure everything by ourselves. That means no protocol is running behind this concept. And whenever we talk about the dynamic, like when we were performing the dynamic routing, we have discussed OSPF, we have to discuss BGP, and there are a number of dynamic routing protocols. Similarly, whenever we talk about the link aggregation group, there is a dynamic way, which we call as LACP. Link aggregation control protocol. Link aggregation control protocol. So we have two methods to implement this concept. One is by static way and the other one is by dynamic way. So how we do that? Let me show you. So here you can see. So can you see that? Let's look at this. Okay. So the basic concept of link aggregation is Ethernet link aggregation, also called ETH trunk. Normally we configured as interface ETH trunk. Ethernet trunk means ETH trunk. ETH trunk. This we call as ETH trunk. Link aggregation and ETH trunk. So what we do in this, we bundle multiple physical links. We bundle multiple, these are the multiple physical links. And what we do, we bundle them. We bundle them all together. To do what? To form a logical link. And what is our purpose? We want to increase the link bandwidth. We want to increase the link bandwidth. And the bundle links backup of each other. If, for example, this link goes down, again, if you have created this bundle dynamically, the both links will create the logical bundle. If you have three physical interfaces are the part of the bundle, but one of them goes down, then the group, the logical group, this logical group will consist of two physical interfaces. So what is the purpose? This is the main purpose, and this is the definition of link aggregation. This is the basic concept, that Ethernet link aggregation, also called each trunk. What we do, we bundle multiple physical links. We have three physical interfaces. We bundle them into a logical link, and what is our purpose behind this? We want to increase the link bandwidth. And the bundle links are the backups of each other to increase the reliability. So we can increase the bandwidth. We aggregate the interfaces to some of the bandwidth of the member interfaces, high reliability. And whenever any active link fails, traffic on the active link is switched to another active link, improving the reliability of the link aggregation interface. We can perform load balancing as well. And a link, like in a lag, traffic is load balanced among active links of member interfaces. So traffic will be distributed on all the interfaces. Some of them will passing the first link, some of them will be using the second link, some of them will be using the third link. So you are doing the load balancing by creating this each trunk, by creating this lag, link aggregation group. You got my point? So there are two ways. To configure the link aggregation group, and one is called the manual mode. Manual mode means the static way. So how we do that? By using the static way, but the manual mode. This is our roadmap. These are the steps we need to follow. So what we do, to create an logical interface, which we called as each trunk. So we'll create interface each trunk. And we take the physical interfaces and bind them with this logical bundle. Just like we create a VLAN, and by creating a VLAN 10, I go to the physical port and map this port with this VLAN. And the VLAN is a logical concept. We don't physically divide the switches. We don't physically break the switches. It's a logical concept. So in a similar way, we create a logical interface each trunk, and give it any number, any integer value, 10, 12, 13, whatever you want. And then in this bundle, you have 24 ports on a switch. So you need to select which interfaces are going to be the member of this bundle. You can select 2 interfaces, you can select 4 interfaces, you can select 8 interfaces. These are the recommendations. Although you can select 3 interfaces, you can select 5 interfaces, but whenever you try to select 3 interfaces, whenever you try to bundle 3 interfaces, you put the last interface for the backup. For example, if this first link goes down, obviously the rest 2 interfaces will create the bundle. But this happens when you use LACP protocol, not in the static way. So what we need to do, we need to create the logical interface by each trunk, and we add the member interfaces to each trunk to increase the link bandwidth. And then you will create VLANs and add the interfaces to VLANs. For example, you can have VLAN 10 at this interface. You can have VLAN 20 at this interface. The first three would be a member of each trunk. And for example, port number 4 is mapped with VLAN 10 and port number 5 is mapped with VLAN 20. And the same configurations you need to do on the other side. The first 3 interfaces, you will bundle them into the logical interface, and the port number 4 and 5 and 6 and 7 and so on, you will bind them with multiple VLANs. You can bind them with the same VLAN, you can bind them with the multiple VLANs. It depends on the, it is the requirements of the network. That what's the requirement. And how we do that? There are the configurations. So normally, how we can do that? Obviously, we will take two switches. We will take two switches. Let me remove this. I will take two switches, any two switches, and I will connect them with each other by the physical interfaces, port number 1 with port number 1, port number 2 with port number 2, and port number 3 with port number 3. And let me start these devices. And you can see the working of STP. You will see STP will put two ports from all of them into the block state. So let me show you again the results of STP. So display STP brief. You can see STP has put two ports, port number 2 and 3 into the block state. So that's what STP do in usual cases. So what we are going to do, first switch, we will name it as name A.
Mr. Hamid. Hello, Mr. Hamid.
Yes, I'm listening.
I remember that you said STB just block one line, not two interfaces, just one interface.
Oh, STP put one interface into the forwarding state and the rest interfaces will put it into the blocking state.
Okay.
Right? It simply put one interface into the forwarding state and the rest two interfaces it put into the block state. I didn't mean that.
Okay.
Okay. So you can see over here, you can see. So how we do that, how we create a bundle of these three physical interfaces. I will simply jump into the first switch, switch A, and I will create interface each trunk, and you can put any number from 0 to 63. You can select any number, for example, 10. All right. And you can set mode manual. You can set mode manual and load balance. You will trigger the load balancing as well. And load balancing on which basis? On the source and destination MAC addresses. So what I have done, let me show you, display this. I've done this. I simply created an each trunk with any integer value, and I'm just performing the load balancing on the basis of source and destination MAC addresses. Okay. I need to do the same thing over here. I will create an interface each trunk with the same group number, and then we are going to select the mode manual because we are configuring this bundle statically. Okay, and you need to perform load balancing, and load balancing on which basis? On source to destination MAC address basis, and that's it. Now you have created the logical bundle, and how can you verify? Display each trunk, for example, 10. You can see we have created this bundle, but none of the port is a member of this bundle. So we need to map these three physical interfaces with the logical bundle. So how do we do that? Simply, we will go to interfaces, for example, interface gig 0/0/1, and you will ask this interface to be a member of each trunk. And that's it. That's how you map any interface with the logical bundle. And that's it. And you need to do the same thing with all the interfaces. Obviously, you will go to another interface for interface 2, and you will put them into the bundle, and then you will go to the third interface, and then you will say be a member of each trunk. That's it. and you need to do the same configurations on the other side. For example, the interface gig 0/0/1, and then you will say each trunk 10, and then to the other interface, and you will say, okay, fine, be a member of each trunk 12, which is your logical bundle, and then port 3 and the each trunk 10, and that's it. And also, this bundle should be configured as trunks. So how you configure that as trunk? Obviously, you will jump into this logical bundle interface each trunk 10, and you will set it as the trunk. So port link type should be configured as trunk and the both sides. Okay, interface each trunk 10, and you will say port link type should be configured as trunk, because multiple VLANs traffic will be passing through this logical bundle. So you need to configure this as a trunk port, So now you can verify by giving the same command, display each trunk 12. Each trunk does not exist. But this is the bad behavior of the switches. Display each trunk 12. No, the trunk port does not exist. Okay, just let me quickly show you one thing so that you guys can believe what I'm trying to say. I do multiple trainings of SCI, and in SCIE we have multiple switches. For example, this is the latest class I have started of SCIE, and just me quickly upload this topology. This is SCIE lab. So I just wanted to show you in some switches it shows you the result, but in some switches it does not show you the results. This is SCIE lab, and you guys can see we are bundling these two interfaces. So let me load this topology. Let me start this. By the way, this is SCIE lab. This is SCIE lab, the expert level. So I'm disappointed by the simulator. It didn't let us verify the MSTP. Also, it is not displaying us the result of the each trunk. And I just came here to let you know, people, I can verify the MSTP and each trunk as well, because this is our normally sessions all the time. I'm giving a session on SCIE labs. So I'm not able to show you the results. So I'm disappointed by this side. So you can see this is switch 1 and this is switch 2, and between them we need to create a bundle, and I will show you the results and the commands, and they would be showing us the results. So I need to take the console. So this is over switch 1. Let me drag it to switch 2. Okay. So this is switch 1. This name as switch 1, and this is our switch 2. So this name switch 2, and let me load the configurations as well of both the switches. Should we write all the commands? Let me load the configurations of these devices, import the configurations. Okay, let them boot. Now they have boot up switch 1 and switch 2 as well. So the same command I'm trying to give over here. So display interface each trunk 12. So you guys can see this command is running and up, and you guys can see the both member interfaces, the port 23 and 24, they are the part of this each trunk. So that was the problem I was facing on your lab, but we do all the time. And you can see I have run the same command, display interface each trunk 12, and you can see is showing me the status each trunk 12, current status is up, link protocol status up, and who are the members of these each trunk, port number 23 and 24. And you guys can see these are the ports 23 and 24. We have bundled them together by static way, and I can show you the commands display current configurations that what we have done over here. So let me show you these commands. I have created an interface each trunk 12, port link type as trunk, and load balancing on the sources of MAC and destination MAC addresses. So we have done this. Also, you can see the same configuration of STP. STP regional configurations and Huawei and regional level is 12, instance 10, and we have mapped with VLAN 10, and instance 20, we have mapped with VLAN 20, and the same configurations we have done over here. And you guys can see, I can show you the results, display STP instance 10 brief. So you guys can see, it's showing me the output by giving the same commands. And these commands were not be able to run in our previous lab. So there is some kind of issue with those switches, but these are some different switches. So we don't have them. We have taken this topology from the Huawei. So I don't know what's the issue over there, but here you can see the same configurations and the same concepts you can see over here. Guys, are you with me?
Yes, yes, we are with you.
Yes, with you.
So it doesn't matter are you guys gonna believe or not, but I'm showing the reality. The same commands I was running over there, and they was showing no impact, but the same configuration and the same command I'm running over here, and you can see the result. On obviously on switch 2, you can also see the each trunk display interface each trunk 12, which I have created over here. So you guys can see these are the member interfaces of the logical bundle. All right, but this is the SCIE lab. SCIE lab over here. All the configurations and all the commands runs, and we can generate the result. But I don't know what's the issue with that simulator, with that topology, with that model of the switches. So that's it. So I have done a lot of SCIE sessions with different guys. There are a number of badges I have done. I never faced this issue in this particular lab, but I don't know what's the reason. Okay, just forget about it. So just do practice on your simulators and just verify either this is running on your side or not, and then let me know. So we have done this by configuring the manual mode, and still we have another way of doing the configurations, and that is LACP. LACP is a dynamic way to configure the link aggregation. The same scenario over here, but the requirement is different. And what's the requirement? The requirement is you need to bundle 3 interfaces. Example, this one, and this one. But in this bundle, first two interfaces, interface 1 and interface 2, should be in active state, but the third interface, which is interface 3, should be in standby or backup state, in the backup state. Why? Because if this link goes down, or it might be the second link, any of them goes down, the second link and the backup link will create the bundle automatically with the help of this LACP protocol. So normally, if you have, for example, 5 physical interfaces and you bundle them together, but only you will put 4 physical interfaces into the active state and 1 will stay in the backup state. Backup of what? If one of them from all the 4 links goes down, automatically they will include the backup link into the bundle. All right. So that's the reason we use LACP. So how we can achieve that? Simply, we will change the priority of this link, LACP priority as 100 and LACP priority as 100 for the 2 links which we want them to act as active. And the rest, we are not going to play with the priority of the third link. So we will increase the priority of the first 2 links and they would be in active state, but the third link will stay in the backup state. So how can we do that? How can we achieve that? This is very simple. Let's check the configurations. First of all, the same thing, you need to create interface ETH trunk 1. Then you will change the mode as LACP. Last time we set the mode as manual. If you set the mode as manual, that means you are configuring this bundle as a static way. But if you write the mode LACP, that means you want to enable the protocol. You want to enable the protocol. Yes, you can put more than 1 backup link. This is for sure. So let me do the configurations over here, but again, I'm not sure it will show you the impact or not. So don't blame me if this simulator don't show me the results, okay? But what I want to show you the commands so that you can understand this concept easily. So again, I'm taking 2 switches. Okay, fine. So again, you need to connect them together. And again, I'm saying I'm not sure it will show you the impact or not. So just I'm going to show you the commands. If someone give any chance to do the labs on the physical devices, please just do it. Just do it. So in the perspective of commands, the configurations are same. The configurations are same. Nothing is changed. Again, you have switch 1 and switch 2. For example, this is our switch A. And I need to create an interface ETH trunk 12, any number. And then you will set mode. And I'm putting the question mark. You can see you have the manual mode and you have LACP. You have LACP. So you can set LACP setting. Again, this model is not supporting the LACP. You guys can see LACP static. Again, this is static. This is static. Okay, so I need to try on the other switch if this model supports LACP or not. So let me check over here as well. Obviously, this is simulator, so there are some restrictions. We are not using the physical devices, we are using the simulators. So we face some challenges when we use the simulators. Okay, so don't you worry. We need to verify if these models supports LACP or not. interface each trunk and any number, and you need to check mode and put the question mark again. This does not mode LACP. No, this is LACP static, not the dynamic. So your switches does not support LACP. So you can take the concept. Obviously, I want to change the mode LACP. So you change the mode LACP, and then you can set the priority LACP, and then you can change the priority. You can change the priority because what you want this interface, first interface, the second interface to act as a active links, and the third one should act as the backup link. So you can set that as well. Okay, so this is the ETH trunk, and you need to go to the interfaces. For example, interface Ethernet 0/0/1, and you can set the you can make them member of your logical group ETH trunk 12, and you can see, guys, he's saying ETH trunk does not exist. I have created that. I have created that interface ETH trunk 10. I guess I have okay, forget about it. I have right 12 instead of 10. Okay. So again, you will map them with ETH trunk. You will map them with ETH trunk. Okay. So here, to go to interface ETH trunk 1, and you need to set mode LACP, and the same configurations you will be doing on the other side. This is on switch A. Obviously, you will be doing the same thing on switch B. You will create an interface ETH trunk with any number, and you will set the mode as LACP. This is your step number 1. And what is the step number 2? Obviously, you need to add the member interfaces. You need to map all them. The first 3 ports you need to map with this ETH trunk. This is the second step. And the same step you will be doing on switch B. You will be accessing that same interfaces, and you will map them with the logical bundle. You will map them with the logical bundle. That is your step number 2. And what is the step number 3? Again, you will go to interface ETH trunk 1, and you will set maximum active link numbers. That if you are bundling 3 interfaces, you need to mention how many of them you want as active interfaces. So you will set that condition inside the interface ETH trunk 1. Maximum active link number should be 2. For example, if I'm having the bundle of 5 interfaces, 1, 2, 3, 4, 5, you can set 3 maximum interfaces, and obviously the rest 2 will be selected as the backup. Okay, and then you will go to every interface and you will set LACP priority 100 just for the 2 interfaces which you want them as an active. You need to increase the priority of that interfaces for the LACP. So these 2 first interfaces, right now we have 3 interfaces, 1, 2, and 3. I'm increasing the priority of first interface and the second interface so that they act as a active links, and I'm not changing the priority of the third link. So by default, it will be acting as the backup. It will be acting as a backup. So that's how we do the configurations for LACP. And the same configurations I need to do on the other switch, on switch B, the same configurations. And what is the next step? Next and the last step is you will create the VLANs. This is optional. This is optional because, you know, in the diagram, these are the 3 physical interfaces which we want them into the bundle. And here is the interface 4, and there was interface 5. We are binding this interface with VLAN 10, and we are binding this interface, which is 0/0/5. We are binding them with VLAN 20. All right, so this is optional. You can do that, but just for the sake of the configurations of the LACP mode, you only need to do that on the first 3 interfaces. So that's what we have done before, to create VLANs, to make them member with the interfaces. And then obviously this each trunk should be configured as trunk, and you need to allow this particular VLAN, these particular VLANs onto the bundle. And that's it. So these are the configurations of LACP. You can try at your own, but in my ANSP, I don't know what's the issue, but the same configurations, if I do into a CI lab, they show me the results, they show me the impact. But when we create a topology in the ANSP, all the other topologies that were working before in our first lecture, in our second lecture, we were seeing all the results, but some of them are not spotted by this. So Afnan send me a link. What is this, Afnan? I'm just opening it. Okay, you are sending me the guidelines. So we are doing the same thing. So you can see that same command. That's good. That's good. Can you see, guys? This switch is supported LACP dynamic, and what the options were there in our switches, the LACP static. So we cannot configure the dynamic LACP in our switches, the model which we are using. Thank you, Afnan, for sending me. So I have already shown you. Let me check on that switches. Is there any option? I guess we have checked that. So I'm just jumping into the interface, each trunk. Interface, each trunk. Any each trunk, you can create any other each trunk. And if I put the question mark after the mode, we don't have any option. This is LACP static only. And the documents which is sent by Afnan, you can see there is an option LACP dynamic, and we don't have this option right now. Okay, and you guys can see the same configurations, interface each trunk, LACP maximum active interfaces, and then you change the priorities of the interfaces which you want them as active. And the third link we don't configure. And you can see it is showing the output, but if we run the same commands in these switches, we don't see any impact. So you guys can see. I hope this is clear to everyone. I'm sending you this link right in the chat box so that everyone can see this document. I'm sending this to everyone. So you guys, you can see that document as well. No, this is not related to. This is not related to each trunk. The commit command is not related to each trunk. Okay. Commit command, it not necessarily for the each trunk. All right. So guys, any question? Any question till yet? I'm not getting any response.
It's clear.
In today's session, I was like, I'm talking with walls. I didn't get any response from all of you, but for the few people, all the time they were participating in the class, but the rest of the guys, I didn't see any message in the box, and I didn't listen any voice. Okay, guys, I guess we have another big topic, and this is really very big topic. We can't cover this topic into 20 or 25 minutes. That is BGP. And even if I take the complete session of today's session for the BGP, that was not even sufficient. So BGP is a very big protocol, and there are a lot of things in BGP. So normally we take 20 classes, and each class of 2 hours, then we are able to complete this topic. So I don't know how they have designed the course outline for day 3, because you guys can see we are continuously learning the things, but still we are unable to complete today's course outline because there was a big topic like STP was a great topic. Then we need to discuss RSTP. Then we have discussed MSTP, and before that we have discussed the VLANs, and then we have discussed about the link aggregation group. So still we have BGP, but we are not able to continue BGP in our today's session. No, there are some switches which sports LACP. It sports LACP. For example, let me show you one more thing. Let me show you one more thing. For example, this is the first question of SCI lab, and in that lab, what he says, just look at that. Assume that switch one does not support LACP. Switch one does not support LACP. That means there are some switches which don't have support of LACP. So this is the first question of SCI lab, which we are doing right now. The first question, you guys can see the commands. You guys can see the commands. So normally we create and each trunk give any number. If we do by manual, we set the mode manual load balancing, and then the member interfaces, we map them with a logical bundle, and that's it. So it also says S1 does not support LACP. That means there are some switches in the market of the Huawei, and they don't support LACP. Okay, so this is not a big deal. I hope this is clear to you. Yes, Afnan, is this clear to you? Okay, thank you.
I have a question,
Sure.
but I have a question about the test.
Okay.
Do you have info about the test, or should I
No,
ask Virus?
literally, I don't have any information about your test because you are not the same region. So
Okay.
the students in the Pakistan have already appeared in the national final, but I guess there is some delay at your side, isn't it?
I don't know.
Okay, so Huawei have the regional policies. So in Pakistan, they have done with the national final, but obviously at your side, I don't know what's the exact date. So you may ask from.
By Thursday, next Thursday, or final.
Thank you, Mal. So further information about the test, you can ask from the relevant resources. I guess Rose over here to deal all the queries from you people. All right.
Right. Thank you.
So guys, tomorrow is our last day, and we have three big topics to discuss. One is BGP. We will start from BGP. Then we will be discussing the security device, and then we will be discussing WLAN, the wireless local area network. So we really have a big and very important topics in our tomorrow session. Normally they have put BGP in today's course outline, but you people can see that was impossible to cover all the topics in one lecture. So I hope you understand. So we will start from BGP tomorrow. Then we will be discussing firewall, and we'll be doing some labs, and then we will be discussing WLAN, and we can do WLAN labs on ESP, but there are again some restrictions on the ANSP. But still, we will do the lab. But again, we won't be generating any results of WLAN deployment. So don't you worry. We will cover a lot of portions. So is there any question you can ask? Otherwise, I'm going to wind up today's session. And I have sent you the link on the group. So you need to fill that form, which I have sent you in the group. So there are some questions. So you need to read them all, and you need to fill that form, and you need to submit. So this is my request, and it will take only 1 minute only. So it will take only 1 minute. So don't be lazy, just do it, because we need to provide these stuff to Huawei. So it does matter a lot. So feel free to fill that form and please submit after the class. It will take hardly 1 minute. Okay, class, is there any question?
Mr. Ahmed, regarding tomorrow, we have an election in Kuwait. It's about the parliament. Yeah. So is there a chance to postpone at least the lecture 1 hour later, or I don't know if it's any fine with all. Well, we watch the video later if we just missed it.
Okay, Mohammed, this is not in my hand to delay the class or to postpone the class. So if there are some circumstances in your country, so you have to put that request to the relevant resources, okay? Because this is not in my hand. I cannot do by my side.
Okay, thank you, sir.
Okay, thank you. Yes, guys, any other question? Afnan and Ahrar, please, after the session, just share the link of the recorded video, the recorded session.
Okay, no problem.
Thank you.
Thank you.
Okay, class, we'll see you tomorrow, inshallah, at the same time. And Mohammed, if you talk with some resources, if there are really some circumstances out there, you can ask with the resources and let me know if there is any change. Okay.
Inshallah, I will chat with her in the group.
All right. Okay. Thank you so much. Thank you so much. We'll see you tomorrow, inshallah. Till then, take care. Take care. Allah Hafiz.
Inshallah.
Inshallah. Take care.
Yeah. Thank you, Doctor.
Thank you.